process analysis with multiple product types. When we have more than one product type that is processed by a given system, the analysis of bottleneck and the analysis of capacity becomes much more complex. Consider this example. This is a process for reviewing job applications. It has 5 steps: filing, contact faculty or other persons, contact prior employers, benchmark grades, and confirmation letter. And there are these intermediate inventories just so that we have some decoupling of those steps, right? They can operate roughly independently. We know how long it takes to process each application, right? So the A here stands for applications, 3 minutes per application to file, 20 minutes per application to contact faculty or other persons, and so on. And we also know how many workers are put for each of these types of activities. So we actually know the resources allocated to do each of those activities. Now, what I want you to realize is that it's not easy to define a bottleneck in such a process. So imagine if consulting applications, there was actually a lot of them, much more than staff and internship. Perhaps the bottleneck could become contact faculty or other persons, right? This is used by consulting applications. And if there is a lot of them, the workers allocated to this part, to this activity, would not be able to cope. However, if there was very few consulting applications, then the workers allocated here would have very little work to do, and therefore they would be very underutilized, and perhaps this wouldn't be a bottleneck. And so it's very difficult to actually define a bottleneck in a process with multiple products. Which actually you will see that it will be inappropriate to talk about a bottleneck, because the bottleneck, if you ever want to define a bottleneck, everything depends on the proportions of the demand, right? It depends on how much demand we have for consulting applications, staff, and internship. Without this demand information that is given here, right, applications per hour, these are actually rates. Without this, we cannot define, we cannot analyze this process. We wouldn't know where the problems would occur, right? So you will see, we will not be able to actually define objectively a bottleneck. We can only point out where there are problems with insufficient capacity given a certain demand. And second, we will actually not be able to define process capacity in this case, because the capacity would be measured in what? In applications per hour, but it all depends what type of applications per hour, right? So we cannot define simple process capacity, and we cannot define a bottleneck. So what can we do in this case? I created here a table which will help us analyze this process. And what we will do here is basically we'll try to calculate implied utilization, because implied utilization will tell us where the problems are. If implied utilization is below 1, we can cope with the demand. We have sufficient capacity for the given demand. And if implied utilization is more than 1, then we see that we have insufficient capacity. So I listed here the 5 activities that we have: the time per application to process on each activity type, the number of workers, and also I listed here the types of applications that visit each activity, right? Filing is needed for all types of activities, but this step is needed just for consulting applications, this step for consulting and staff, this only for internship, and the last step again for all application types. So now I will actually calculate the demand and capacity, but I'm going to use a special unit to be able to aggregate the amount of work or the available amount of work on every step. Now, in this example, you could actually use a unit of applications per hour. Why? Because on every step, each application takes the same, each type of product, right? Each type of application takes the same time. For example, here, right? It takes 3 minutes to process any type of application. However, in general, it could be that maybe consulting application could take 4 minutes, staff application could take 3 minutes, and internship could take 2 minutes. In this case, you couldn't determine capacity objectively as the number of applications per hour, but you can actually determine the amount of effort of work, which I measured in minutes, right? This is effort per clock hour. So I am going to use this more general unit so that you can solve any type of example using the same method. So capacity will be defined as, remember, minutes of work per clock hour. If I have one worker, the worker can work 60 minutes every clock hour. If I have two workers, then obviously they can work in parallel, and I have 120 minutes per hour. And notice right now, hope you understand, there is 120 minutes of work that those two workers can do together over 1 hour of real time, right? Three workers, by analogy, will be 180. Again, two workers here, minutes per hour, 120, and one worker, right? So the unit here is, remember, minutes of work, minutes of effort per clock hour, right? And now the demand is a little bit more complex. So I can calculate the demand as thinking as the following. It's 3 minutes per application, right? Times every consulting application. And if you recall from the previous slide, it was 3 consulting applications per hour, right? And I could add to this, again, 3 minutes per application times all the staff applications, which were 11, right? We have all 3 types of applications here. And again, 3 minutes of work per application times 4 internship applications per hour, right? This is also applications per hour. Now, because all 3 products take 3 minutes, right? I can actually aggregate this. I can just say, right, regardless of which product this is, I will take the 3 minutes per application, right, in front of this calculation, and I will just say 3 minutes for every application per hour, right? 3, 11, and 4. And again, because these are the same units in this case, application per hour, I'm going to just simplify it even further and just say this is 3 plus 11 plus 4 applications per hour, right? But remember, the original writing was more flexible, because if I had 3 different time per application of different, right, per consulting, per staff, per internship application, I can disaggregate this calculation and actually see all the effort that needs to be made on this activity by the workers that are actually working in this step. So it will be, right, 3 minutes times 3 plus 11, 3 minutes per application times 3 plus 11 plus 4, that's a total of 18 applications per hour. 3 times 18 is 54. And if you divide by application, per application, and then application per hour, the application can be reduced here, and you're just left with a unit minutes per hour. And recall, this minutes is, in fact, minutes of effort. It takes 3 minutes of work to process an application, right? And this is applications per clock hour that we are receiving. This is our demand, right? So the unit is correct. It's the same unit as the unit of capacity, right? Similarly, I can do the calculation here, 20 minutes per hour per application times how many applications is just consulting applications, which are 3 per hour, right? So I can calculate this as 60 minutes per hour, minutes of work per hour of time. The next one is 15 minutes per application from this column, right? Times which application arrive here, right? So again, I can already consider them aggregated, and recall this is the first 2 of those 3. So it will be plus the 3 plus 11 applications per hour equals 210 minutes per hour. And this is 8 minutes per application times only internship 4 applications per hour, which will give me 32 minutes of work per hour. And this finally is 2 minutes per hour, minutes of work per hour times all 3 types of applications per hour. That's going to give me only 36 minutes per hour, because it's very short time per application, just 2 minutes, right? So now that I calculated those two, I can now calculate the applied utilization by dividing this value, demand, by capacity for each resource. So, or each activity in this case, right? Because there's multiple resources maybe on each activity, 1 or 2 or 3 workers. So this will be 54 minutes per hour divided by 60 minutes per hour. I'm going to skip the unit because the units are kept uniform here. The same unit is here and here, so it will be reduced, and I will just have a unitless value, 0.9, which is 90%. Here it will be 60 over 120. It will be 0.5 or 50%. This will be 210. Oops, sorry. 210 divided by 180. Right, this will be 1.70. This will be 32 divided by 120. That will be 0.27 or 27%. And this will be 36 over 60, which will be 0.6. Right? So I hope you see there is a large imbalance between the implied utilizations. Right? This one is the lowest. We actually have 2 workers here, and they utilize 27% of time if we process all the demand. And the highest one is here. And actually, this is where the problem is, and this is the interesting value. Right? The implied utilization, it says here 117% or 1.17. Right? So this is an indication that we will have a problem processing all the demand, right? So can I define process capacity? Well, it's hard to define it. I mean, what I can for sure say is that the capacity is insufficient to process the demand, right? Because the implied utilization on one of the steps, at least one of the steps, if it is more than one, I cannot process all the demand. But in fact, this is just limiting consulting and staff applications. It is not limiting internship applications. So actually internship, I can process all the demand, right? Can I define a bottleneck? Can I say this is a bottleneck? Actually, some books would say, yes, the implied utilization is more than one. This is the bottleneck of the process. There's only one implied utilization. But what if more than one implied utilization is over one? Or what if there's no implied utilization more than one? All of them are less than or equal to one. Is there no bottleneck in this case? I think it is not a good idea to talk about process capacity and bottleneck in this case. Right? I would say it is undefined, and bottleneck is also undefined. Right? So what we can talk about, which I think is more appropriate, is that from the above analysis, we can say that contact prior employers is what limits flow rates for some product types. In this case, it's the consulting and staff applications, right? This is what I think is more appropriate to say, right? So we can actually say that we have a constraint that is going to affect what we can do. But now to say exactly, for example, what we should do about this, there are multiple options, right? So for example, if we just leave it as it is, those workers, those 3 workers, will not be able to process all the demand, right? They won't be able to process all the staff and consulting and staff applications. Therefore, they probably will start processing less. Maybe some of them will feel obliged to work overtime, right? But if they don't want to work more than they are expected, what they are expected, then these applications will not be all processed, and then there will be a buildup of inventory, right? So we will actually not get all the applications processed. In the long term, you will see actually a lot of buildup of inventory. We could address this. We could actually ask them to work overtime, maybe pay extra for this overtime, and they could process all this extra, do all the extra effort. However, we could propose something else. For example, we could observe that here we have implied utilization 27% with 2 workers. Actually, if there was only 1 worker, the capacity would be 60, and this would still be enough to process 32 minutes of work, right? So I could shift one of those workers put them here, this would be an obvious improvement, of course, provided that the worker is qualified to do another step, right? And that could actually increase capacity here to 240, and the implied utilization would become less than 1. So there are many ways to address this, and it's not easy to just say this is the bottleneck. I mean, you could, simplifying the case, you could say this is a bottleneck, but really what we detected is that we have a constraint, something that will limit the processing by this process, so all the demand will not be satisfied. So to summarize, process analysis with multiple product types, first thing that we discover is that analysis requires demand information, right? And without it, we cannot really figure out where the bottleneck is or what the problems are, right? Once you have demand information, we can calculate implied utilization for each resource, right? If all resources have implied utilization less than or equal 1, this wasn't our case, but if this was the case, then we could say flow rates will be just dictated by the demands. We can satisfy all the demand, let's process all the demanded units, right? Let's produce or serve according to demand. But if some resources have implied utilization, more than one, at least one, maybe multiple, then we know that the flow rate for the products that visit those resources must be reduced for, right? Flow rates for those products must be reduced below demand. Now, how we reduce this is still an open question, right? In our example, we could have reduced one of the applications or the other. We could have given a priority to one application type over another, right? We could have reduced them proportionately or do something else. Alternatively, we can try to somehow increase the capacity of those resources, right? So improve the process capacity, right? You could do this through overtime, you could do this through reassigning workers or other, using other means. In general, if you want to find, for example, under this case, how to what flow rates should be right assigned to every product. So how many units of each type of product you should process? One can formulate a problem, an optimization problem with profit maximization, and this problem can be solved using linear programming. This kind of problem, when you solve it, it can tell you how many units of each product should be processed per unit of time. So it can tell you the flow rates that will maximize the profit, right? And it will also actually tell you which resources were actually limiting the flow rates. So which of course could be all those resources with implied utilizations more than one, but sometimes it's just a subset of those resources, right? So in this case, you will actually see a set of binding constraints which will be related to the activities that we had and activities and resources that perform those activities. So my final point is that in the case of multiple product types, it is more appropriate to talk about constraints that limit the flow rates rather than about bottlenecks or process capacity, right? If you see implied utilization is always less than or equal 1 on all resources, the demand is the constraint, right? We could produce more, but the demand is limited. If implied utilization is more than 1 on one or more resources, then we also know that these resources are also constraints on our flow rates.